Hi, I am Salahuddin. Today I am here to discuss Decorator Design Pattern. It is a structural pattern. First, let's see what do we need to use Decorator Design Pattern. Here we have a class hierarchy where viewer is the interface and the text viewer and image viewer are the two classes. The object of text viewer, suppose TV, displays text, and the object of image viewer, suppose IV, displays images. But the problem is that if the window of the text viewer cannot hold all the text at a time, then we need to add a scroll bar with the text viewer. We can add the scroll bar with the text viewer by simply adding a subclass, that is by inheriting from text viewer and add the behavior. Suppose the class name is text viewer scroll bar, and now we can add the behavior, add the scroll bar, and if we create an object from the subclass, suppose the object of the subclass is SB, then the object will be able to display the text viewer and also with the scroll bar. But the problem is that we need the scroll bar during runtime, and on that case, first we need to create an object from the scroll bar, and then we have to copy all the information from TV to SB, and then we have to destroy the object TV, and the whole thing is messy and also error prone. Actually, to solve the problem, Decorator Design Pattern has come. Actually, Decorator Design Pattern solves the problem without destroying our existing objects, but Decorator Design Pattern gives a way to add behavior with the object during runtime dynamically. Let's see how Decorator Design Pattern do that. First, we need to add a subclass for decorator. And to hold our existing object, we need a variable here. But suppose it is here. Decorator constructor and display. Actually, the class decorator, it is also a component of a component type of interface. Actually, the decorator class holds our existing objects and use that. We will see the implementation here of the class. Suppose it looks like class decorator, the variable here viewer, here, and public decorator constructor. It will accept the object, that is viewer type, VW suppose, and it will store into here VW, and the function display actually works like void display it actually call our stored objects display function, that is VR display. That is, by calling this, it will call our text viewer display function or our image viewer display function. And now we will add the behavior, additional behavior with our existing objects. Suppose scroll bar, constructor of scroll bar, the function will override the display function, and also the additional behavior, that is add scroll bar. And the class and the implementation of the class looks like class scroll bar public scroll bar, it will accept our existing objects, that is viewer type, VW, and it will pass to its base classes, as the base class accepts the object, that is decorator, and now we will add the add scroll bar void add scroll bar. The function actually will add a scroll bar with the text viewer or image viewer, and the display function will be like it will override our base class display function. So here it will be like first call its base class display function, that is decorator display function, it will call first, and then it will call its own class function add scroll bar to add the behavior with our existing objects. Add scroll bar. Actually, decorator design pattern wraps our existing objects and adding new behavior with the object. Now let's see how client will use this pattern, those classes. Suppose the client have a existing object of a text viewer type, suppose viewer text viewer, new text viewer, and if client now call text viewer display function, then primarily it will display the text viewer, and the client actually has the primarily this text viewer object. Now client need to add the scroll bar. Now how client can add the scroll bar without destroying this? Simply by using an object of scroll bar. It is also viewer type. Text viewer, with scroll bar, equal new scroll bar type an object, scroll bar, and we will pass our text viewer object to wrap up the text viewer, and to add the behavior with the text viewer. Now if we call the text viewer with scroll bar object, the display function, scroll bar, call display function, then this display function actually after calling this, it will add the scroll bar with our existing text viewer object. Actually it works like by calling this display function, it will call its base class display function, and actually the base class display function calls its existing objects, that is our existing objects of a text viewer or image viewer display function, and then it call its additional behavior, that is add scroll bar function, and by calling this it actually adds additional behavior with our existing objects. And in this way Decorator Design Pattern works without destroying our existing objects, but add additional behavior during runtime dynamically. And to get full implementation of the Decorator Design Pattern using C++, please visit my GitHub repository. And thank you for watching the video.